Good afternoon, class. Today we're going to be working with section 3.5, working with sets. So we're going to do some new definitions first, and then we'll work into some examples. First thing we're going to talk about is what it means to be a set and the definition of that. Definition of a set here is going to be a set is a collection of distinct objects or elements. So it's typically written as a list of things. We're also going to talk about what a complement to a set is. And the complement is just going to be everything that's not in that set. So a complement to a set is the set of all objects or elements not in it. So up here I just have a little example of, just a small example of what a set is, 0, 1, 2. So it contains elements. Each element is the number in that set. So using symbols, there's two different ways we're going to represent sets. One is called the roster form. The roster form here roster form is just going to be listing them as all of the numbers in that set. So 0, 1, 2 would be the list. That's roster form. But it can also be written in a new form that you may not be familiar with, which is called set builder form. When you're doing it as a set builder form, you're going to start with a variable that's going to represent the set, and then you describe what that variable is by saying that we're dealing with whole numbers, and whole numbers are numbers that do not have any decimals with them. So the whole numbers, where x has to be less than 3. So if we look at our set here, 0, 1, 2, those are whole numbers that are less than 3. So when we're doing set builder form, we're typically going to be using inequalities to describe what that set is. We first have to describe what the numbering system is that we're going to be working with. So we can also use not just numbers in our sets, we can use items or descriptions. So in this example here, the universal set of all meals in a day, so universal is just the overall set, would be breakfast, lunch, some snack, and then dinner. So if we let A be the set of just breakfast and lunch, the complement of a set is always going to be, if we go back up here, everything that's not in the set. So the complement of A will be the other items not listed here. So the complement would be the snack and the dinner. So let's do an example. So what I'd like to do first here is just complete these sets using similar things. So eyes, ears, nose, and mouth. So mouth would be something that we could add to that set. Mother, father, brother, sister could be added to the set. And then here, AE blank OU, that's going to be I. We're looking at the vowels in the alphabet. So down here, we're going to suppose that the universal set of coins is going to be penny, nickel, dime, and quarter. If we let D be the set of penny and quarter, what would be the complement of D? Well, it would be everything that's not a penny or a quarter in our universal set. So that would be the nickel. Sorry about my writing there, it got off a little. The nickel and the dime would be the two items not in that original set. So using roster form and set builder form, those are the two different ways that we're going to list things. We're going to let n be the set of even natural numbers, okay, that are less than or equal to 12. We got to learn how to write that in roster form and in set builder form. So if we start with all the natural numbers that are less than 12, so the natural numbers are all the counting numbers, 1, 2, 3, 4, all the way up to 12. We're talking about just the even natural numbers. So we're going to deal with 2, 4, 6, 8, 10, and 12. So we would list that in roster form here, 2, 4, 6, 8, 10, and 12. So to build that in, or to put that in set builder notation, we would have to explain what the set is that we're dealing with. And we're going to be dealing with even natural numbers. So the even natural numbers, and we're going to have x be less than or equal to 12. So that when you're doing the set builder form, you first have to describe what do we want x to be. We want them to be even and natural, and we want them to be less than or equal to 12. So that's the set builder form. So inequalities and set builder form. So let's say we give you an inequality, 9 minus 4n is less than 21. We want to build a solution to this and use set builder notation to write that solution. Well, the first thing we have to do is solve for n. We got to know what n is going to be before we can actually get to that. So the first thing we have to do is solve this. So we're going to subtract 9 from 21. That's going to get us 12. One error that a lot of people make is they don't realize that that minus is part of that 4, so we got to keep that with that. So then we have negative 4 times n is greater than 12. To get n by itself, we're going to have to divide by negative 4. And remember, that does something to the inequality that flips it. So n is now going to be less than negative 3. 12 divided by negative 4 is negative 3. So here is the solution to this inequality. So n less than negative 3 is the solution. In set builder notation, we would write that n is going to be a real number, and that it will be n less than negative 3. So that's the set builder notation for that. So we're going to introduce what an empty set is, and an empty set is just written with two set symbols, two brackets, with nothing in it. And this set with no elements is actually part of every set. So it's considered a subset of every set. So we're going to talk about subsets. And as we introduced earlier, a subset is just a small part of a big set or a larger set. So we're going to deal with two sets here. The first one we're going to work with is the set P, which we're going to just have be the letters A and B. So the list of all subsets of P would be A by itself, B by itself, and then the empty set. So sorry about my symbols there. That is not very clean. So A by itself, B by itself, and the empty set would be each subsets of the set AB. So if we're working with a larger set, we're going to work with the set S, which is going to be ABC. We're going to have the empty set, and then we're going to have the single sets A, B, and C. So those would be all of the sets that would be single digits, but we can have double digits as well. So we could have A and B, A and C, and B, C. And then we can obviously have the original set A, B, and C. Oh, that was one I forgot up here. Anytime you have a set, a subset of it can be itself. So we have empty set A by itself, B by itself, C by itself, and then the pairs AB, AC, and BC, all subsets, and then ABC is the original set. The last thing we're going to talk about is working with the complement of a set. And as we defined earlier, a complement of a set is everything that is not in the set we're describing. So we're going to start with the months of the year, and this is going to be considered the universal set, or the set that we're going to pull information from. And we're going to first start with all the months that are exactly 31 days. So I'm going to abbreviate this a little bit. So we have January, March, May, July, and then August, October, and December are all 31 days. To remember that, they go every other until you get to the middle. July and August are the two middle ones. These both have 31, and then they go back to every other again. So that would mean all of the other months, February, April, June, September, and November all have 30 days, or excuse me, 28 in February, but the other ones have 30. So if we let A be the set with exactly 31, A prime will be the set that is considered the complement. So when we go down here to list this, the complement, and we're going to do this in roster form, would be February, April, June, November, and September. Sorry, I flipped those. So this would be the roster form for the complement. And a complement always has a little, it's called a prime symbol, but a little prime symbol up here above the A. So that's it for today. You'll work on a few example problems after the video, and then we'll begin to work on some in class tomorrow. Have a good